Alright folks, Puppy's World here once again. And today I have an interesting topic to talk about, as I am joining you today in the second bedroom, where we are doing a small, well, I'm not going to call it a theater build, but I'll call it a small home surround sound setup utilizing Dolby Atmos and DTS:X, and more specifically height channels. And I have chosen to take my surrounds and technically what most people call surround backs and utilize them as height channels. Well, with this interesting but minimalistic bare setup. Now, I just wanted to talk about something really quickly, as there's lots of confusion about this, either on the internet or in literature whatsoever. But I'm going to read you something that's concerning specifications of HDMI. And there's been a little bit of confusion of audio return channels and hooking up your television via HDMI through your audio return channel and then sending that signal to your receiver and then amplifying that to the speakers and then experiencing Dolby Atmos. As opposed to PCM, Dolby Digital, Dolby True HD. I do know I have a unique setup in my home here where I'm able to go, if I were to just go to cable sat in this room and show you specifically the input signal, it's going to be different in this room than it is in any other room. Why? That's another topic, and it's utilizing a complete different set of input signals than it is in any other room in my house. But that's another topic, that's another video, that's another discussion. What I wanted to quickly talk about now was achieving Dolby Atmos through an audio return channel, specifically on your television, based off of a media server, player, Roku device, or utilizing Dolby Vision, which is a new hot commodity now, HDR10's competition. And I wanted to talk about that versus, well, the conventional setup as to, just running everything HDMI 2.0. And we're keeping things 2.0 in this house specifically because I've done some testing and some debate on consensus over HDMI 1.4 versus 2.0, and if things need to be HDCP 2.2 protected. By the way, HDCP 2.2 just means high definition copy protection 2.2 version, and specified thereof and after and whatnot. But HDMI introduced signaling in the form of the enhanced extended display identification data, the E-EDID structure that allows a source, basically device, set-top box, game console, Roku, Express, streaming media player like this to detect the capabilities of the connected sync device, which is your soundbar, TV, AV receiver, what have you, before sending any audio signal or video. What that does is ensure that only formats that the sync device supports are transmitted by the source device, ensuring no blank screens or silent speakers or anything not working. And what that ensures is the main audio parameters in the EDID or EDID are carried in one or more short audio descriptions, and that's what SAD means, short audio descriptions. But when you get into that topic, each short audio description describes a supported audio format, including sampling rates, bit rates, and PCM bit depths and all that. But I want to give you an example of what that kind of looks like. So here, I'm just going to kind of quote something that I'm going off of here. Not going off of, but I kind of wanted to give everyone a proof. Proof is in the pudding, so to speak. And I wanted to give everyone somewhere to go to be able to visualize or get an understanding of what it is essentially that I'm talking about. So here, I'm just going to go to my laptop really quickly, and I'm just going to show you right here. You're looking at sample rates for pulse code modulation, AC3 and EAC3, which are right here, and 32, 44.1, which is going to be your average sampling rate in kilohertz, 48, that's your highest, 96, which is going to be your highest you're going to see television in, or 192, which you're not going to see television in ever. And for PCM, those are max channels of, well, 2. The max channels of the other ones are 6. So I just wanted to give you an idea of what that exactly looks like converted into bitrate and sample rates and stuff like that. But concerning, and you know, I'm not going to get too technical in this video, but concerning the question of, can I pass, and I know I've got a lot of work to do here with the wiring and whatnot, and I'm going to be using that speaker since it goes to a set of NHT piano glosses that I have as a voice of God, and, you know, another build here. But let me continue really quick. The question I've been asked by a ton of people, and this has been floating around online for quite some time now, is, can I pass a Dolby Atmos signal? This is number 1 we're going to go through. We'll just go through number 1 right now in this video. Can I pass Dolby Vision? I'm sorry, not Dolby Vision, Dolby Atmos from my Roku Media Express player into my TV via the audio return channel, and then pass that out via the audio return channel into a receiver? And the answer is no, you cannot. To simplify things, or, you know, to make it easier to understand for you guys, can I get Dolby Atmos out of my TV, technically, is the question. Whether it's concerning sending an optical audio output signal to the receiver, or going with an HDMI audio return channel, audio return channel into my receiver. And the answer is no. So basically what I'm saying, and it's not too difficult to understand this, but it is going to be for some that aren't basically so concerned with the technicalities that I'm involved with and whatnot. The basic question is, can I get Dolby Atmos surround sound out of anything but sending a direct source to my receiver? And that answer is no. Why? Well, I'm not going to go into the complicated matters in this video as to why exactly, but let's understand 2 things here. Let's understand 2 fundamentals of surround sound really quickly. You know, since Dolby Atmos is not a Kodak, and it's carried as an extension to existing codecs, there's an audio format specific byte in each SAD, and we talked about what an SAD is, that indicates whether a Dolby Atmos, a DTS, you know, X, or a Dolby True HD signal is decoded. A source device that wants to send Atmos to a sync device can check for Atmos support in the SAD for each Dolby audio codec, right? But it's common for television to support stereo pulse code modulation, PCM. Dolby Digital usually, as you see right here, well, this is an older TV, supports Dolby Digital, right? Most TVs do nowadays. Most set-top boxes even do. Dolby Digital, hence why we're getting Dolby Digital out of this cable box, you know, PCM out of others and whatnot. But, like I said, it's common for those things to support PCM, Dolby Digital Plus, and it's common for AVRs and soundbars to additionally support Dolby True HD, Atmos, DTSX, whatnot, and further and so on. When a source device connects to a sync device, though, it reads the EDID to see what codecs it supports before sending that audio. In the case where the sync device does not support the source's audio codec, though, the source device will decode the audio and send stereo or 5.1 PCM audio only, guys. So carrying Dolby over the HDMI, that's a really, really popular misunderstanding or understanding fundamental that we need to kind of get down here. And we need to understand this essentially by doing tests. Some people test it by running an HDMI from the receiver back into their TV as a second channel. Some people test it by taking their source material, like their DVD player, Blu-ray player, sending an HDMI signal directly into the receiver, and then calling it a day and just sending one HDMI signal out to the television or monitor then, and there you have it. You know, people don't really care what audio signal is being sent to the TV thereof, because audio return channel ARCs, ARCs, are not going to pass that back out of the receiver, or I'm sorry, back out of the TV into the receiver, and then be able to, you know, realize the codec it's in. But when delivering the encoded audio formats over the HDMI, the data space normally taken up by the PCM audio data can instead be thought of as, well, one big data pipe where the clock rate determines how much data can be sent across the pipe. So essentially, guys, the 3 main clock rates are important for Dolby codecs. They're the 48 kilohertz, 192 kilohertz, and 768 kilohertz. Yeah, I said 768. The data pipe is 2 channels with a 16 bits per channel. So when you multiply the pipe size and the clock rate, you correspondingly get, and I'm reading this right off of online, guys. I'm not even, I mean, right here. I'm just going off of this. So, you know, when the data pipe is 2 channels with 16 bits per channel, you multiply the clock rate and correspondingly get 1.5 megabits per second, 6 megabits per second, and 24.5 megabytes per second, I'm sorry. Dolby audio codecs fit into different clock rates like this. So this is why I'm kind of showing you this. They fit into the clock rates like this. There you go. There you have it. So why can't I send just PCM? That's a question somebody is asking right here. Why can't I send just PCM? Well, there's a lot more to Dolby Audio than just compression. You get the best possible audio quality when the final... I'm just reading this off directly on here, guys. So I'm not even talking anymore. I'm just going to go directly off of this website that you can find for yourself. There's a lot more to Dolby than just compression. You get the best possible audio quality when the final device in the chain does the audio decoding. Dolby Audio bit streams have metadata parameters that define how surround sound is downmixed to stereo, what type of dynamic range compression should be applied, and other useful information. To get the best sound quality out of a television or home theater system, it's best if they receive a Dolby bitstream over HDMI. Hence the reason why people are always changing their Dolby, well, not Dolby, but their Blu-ray players to bitstream rather than PCM. Bitstream is the best way over HDMI to receive that codec, and for basically the receiver or whatever device is sending a signal to the speakers to decode that or to understand that. It says, you know, continuing reading on here, additionally, there's no way of sending Dolby Atmos over PCM over HDMI. So you have to send Dolby Digital Plus or Dolby True HD to get the Atmos experience. Correct. A couple of months ago, when I first started my YouTube channel and whatnot, people used to argue about, is it possible to get Dolby Atmos out of things that don't have the Atmos codec, you know, little sign on them. Hence, you know, Dolby Atmos, or Dolby Digital. Is it possible to get Atmos out of something that doesn't have that sign? And I can tell you this, it is possible. Like if I take a PlayStation 3 and I run a Blu-ray in there that's got Dolby Atmos, and I send the audio signal into this, it will work. Why? The PlayStation 3 doesn't have to have the Dolby Atmos decoding capability. It's just going to read the disc. It's going to send that signal over an HDMI cable, but you got to keep it 2.0 for these reasons, into a receiver, which can then decode Dolby Atmos and go from there. It's a little bit different than Dolby Vision, guys. I will do a whole video devoted to Dolby Vision, as I've had to do some testing yet with it, with the Oppo 203 and all that, and my Sony XPR 850C model, and then the D model. So I've had to do some working around with that, and then I've had a chance to play around with the Dolby Vision out of the Z models of Sony televisions. That, as of now, those are the only models that are actually running Dolby Vision compatibility through Sony's displays, and going from there. So there's a lot to talk about here, but Dolby Vision is going to be kept to a completely different video that I'll devote all to, you know, the truth about Dolby Vision and whatnot and what it needs to take it. But let's look at this really quickly. The HDMI audio return channel, and this is, you know, illustrating the fact that Dolby True HD turns into Dolby Digital Plus, which came from Dolby Digital. Your ultimate source is going to be the Dolby True HD, though. That's coming from your receiver, or coming from a router or signal going into the receiver and then being amplified to the speakers. Video and audio only. Streaming, whether it be off air, meaning like a DVD or something like that, doesn't matter. Doesn't make a difference. Now here we got Dolby Digital turns into Dolby Digital Plus, which turns into Dolby True HD. Off air or streaming is sent to the TV, and then audio only is sent to the amplifier. This illustration is going to give you the best. Your audio return channel is about talking like this. So the audio return channel is meant to do one thing and one thing only. The audio return channel provides a way for the TVs to send audio upstream to an AV receiver or soundbar. And by upstream, what I mean is one way and one way only. Audio return channels are meant specifically to crosstalk between your receiver and your TV and try to determine input, try to determine, you know, am I playing, am I playing sound through the TV speakers, or am I playing sound directly through the speakers of the stereo system? And, you know, quite some time ago, or not even more than a year ago, we were left with the dilemma of having to either turn down our volume on our TV at the same time as our stereo. And that created a problem. because you'd get the audio coming out of the TV speakers as well as the stereo surround speakers. So that you wouldn't like. Your TV was essentially acting as your full bandwidth center channel, your left and right, and your surrounds and sub, more or less. And then sending that signal all with a delay effect and auto lip sync and all that to the speakers. So you had to turn down your volume on your TV to adjust it to the stereo speakers. However, without HDMI audio return channel, consumers would have to connect their home theater systems using the SPDIF along with its shortcomings. The benefit of audio return channel is that it simplifies the home theater setup altogether. All of your sources plug into the TV and audio is passed through the TV out to the home theater device. TV makers also have simplified device control by using HDMI Consumer Electronics Control, which is CEC, to send commands, which means volume, power, etc., turn speakers on, turn speakers off, home theater speakers versus TV speakers, to the home theater system to give consumers a single remote experience, which has become much easier. You're able to just program your remote to your receiver, which also controls the television through the audio return channel, and you program your DVD player or Blu-ray player on into this guy, and you've got one remote and you're good to go. But audio return channel signaling works similarly to the HDMI forward channel. There's an EDID to indicate what audio formats and features are supported. The key difference between HDMI audio return channel and the HDMI forward channel is how much data can be transmitted, guys. Audio return channels only support 48 kilohertz and 192 kilohertz clock rates, which means that Dolby Digital and Dolby Digital Plus are supported, but Dolby True HD is not supported as there's not enough bandwidth for it. Hence, Dolby Atmos can't be supported, guys. For Atmos, though, Dolby Digital Plus-based Atmos content can be sent via HDMI audio return channel, but True HD-based audio Dolby can't. So what am I saying here? I'm saying, concerning Atmos, Dolby Digital Plus-based content can be sent via the audio return channel, but Dolby True HD-based Dolby Atmos cannot. So we've just learned here that Dolby Digital Plus content can come, Dolby Digital Plus Atmos related content. So if you're getting Atmos out of a Dolby Digital Plus signal, meaning if you've got Dolby Digital Plus compliant devices and a Dolby Atmos Blu-ray and you're running it through a receiver that has Atmos but it's Dolby Digital Plus compliant, sure, you'll be able to run that out of an audio return channel. If it's Dolby True HD, as we just talked about, if that's what it's based with and you're up converting it, sort of converting it speaking to a Dolby Atmos content, audio return channel cannot handle that. What it means is that Dolby Atmos can be sent over audio return channel. It can, guys, but only within a Dolby Digital Plus type Kodak, and it's going to be hard to explain this to people without demonstrating so many different things, but well, not far from now, televisions will be able to transcode Dolby True HD to Dolby Digital Plus to then send Dolby Atmos audio over the audio return channel. So it will happen, guys. And with HDMI 2.1, this is one of the benefits of why I would get on the 2.1 train at some point if I'm not experiencing Atmos through an enhanced audio return channel. Is the HDMI 2.1. As we talked about on my video, I've got another video coming on HDMI 2.1, guys, versus 2.0, so bear with me here as I kind of edit that video and whatnot, but I've got to go through and kind of explain things a little bit more in depth as to what HDMI 2.1 will entail and what it will involve. But it involves something called an enhanced audio return channel. It's lossless audio that can essentially be sent over an audio return channel. And one of the reasons that they bothered making HDMI 2.1 is specifically the fact of problems like this. Problems of if we've got Dolby Atmos enabled sources, through Netflix or whatever, and we can get Dolby Digital on Netflix, Vudu, whatever, we're not getting it through our receivers through an audio return channel. We've got to directly wire our system to the receiver. And what I mean by that is simply this. I've got my Roku set directly into my receiver, obviously. That way I can just go through inputs of hitting the media player, going back to cable SAT, Blu-ray and whatnot, different source. If I want to bring the PS3 or bring the PS4 on in here, if I got a friend that's bringing me an Xbox One S, whatever, hook it all up into the receiver. That's why I'm someone that's very, very confident running things through the receiver. However, that enhanced audio return channel feature out of that HDMI 2.1 is going to involve sending a Dolby Atmos signal basically over it. In the past, though, many TVs have replicated the same audio that was sent over the SPDIF to HDMI audio return channel. While this was fine for stereo and Dolby Digital Plus, as we talked about before, can only be sent over the audio return channel and requires a different higher clock rate than SPDIF. So you need to look into the to giving people Dolby Atmos experience over HDMI audio return channels, it appears, because people don't want to necessarily go from their source material directly on it into the receiver. A lot of people are utilizing their TV for their streaming services, or they're utilizing a Blu-ray player that's got the streaming services on it connected right at the TV, and then they've either got an optical connection leaving the television going into the receiver, or they are doing it the conventional manner, the one the way I recommend. They're taking their Sony X800, PS3, PS4, or they're taking their UDP 203 and they're sending an HDMI signal directly to the receiver, and letting that all do all the audio, capability, and then sending just one HDMI to the TV. Should have no problem. Guarantee you. If you're not getting Atmos, you've got to change that setting in the source material. So now if we're going to do things in an unconventional manner, if we're going to go with two different HDMI outputs, as with the Apple UDP 203 does have, then we're going to go audio out directly to the receiver, but we're going to send our main signal on into the TV audio return channel. That'll allow us two different things. That'll allow us to crosstalk and get faster speeds with the TV if we're going to use streaming services to utilize over our surround speakers that are hooked up to the audio return channel to a receiver. And it'll allow us to do one other thing. We're not going to go into that now because I don't utilize that type of connection. I'm taking all my source materials, going on into the receiver, and then operating that way. However, I do have a Sony in my other room here that does have streaming services on it. I am going out of an audio return channel. I'm not using anything like this, and I'm getting Atmos. Why am I getting Atmos? I'll talk about. I have to do an entire video devoted to that, specifically that. So I'm just going to explain here really quickly that, HDMI EDID signaling tells a source device what the sync device supports. So it eventually crosstalks between the source and the sync. The source and sync are two different things. Those need to kind of match the audio quality for you to achieve Atmos out of something. But Dolby Audio is sent using different clock rates within HDMI. So we need to kind of understand the clock rates if you're going to completely determine if, your audio return channel is going to be able to send an Atmos signal to your receiver. The HDMI audio return channel supports Dolby Audio, including Atmos, as I said, guys. So it should be able to do it. However, there are issues that people are getting with doing that. Some of the issues are, some people, and I have seen this happen for myself too, are only getting True HD coming in, and I can show you. I'm going to have to do a whole video with my 7010. I can't do it with this receiver right now, and the 7010 is actually out of commission right now, guys. I'll have to explain later why, but 7010's out of commission right now, so I can't do it. But the other day, I was playing around with some things, testing some things, actually standing up a 6011 next to the 7010 and kind of comparing the two. Actually, by far, the 7010 blew it out of the water. But another video, and we had an Atmos source, we had an Atmos Blu-ray, running in conventionally how we did into the receiver, then that audio return channel, cross-talking between the TV, and what did we notice? Well, we'd hit info on the receiver, and all we were getting, not PCM, we were getting Dolby True HD, and I'm like, what the hell? What gives here? Why are we getting True HD? One thing it took, and one thing only. All it took was for me to be able to go like this. So I set my stuff up, I went into my audio, and I had to turn off any EQ settings that the receiver was essentially doing. So if I can do my manual setup here and I look at my speaker configuration and I make sure that everything supports Dolby Atmos, I said Dolby Atmos. Okay. One of those requirements is, and a lot of people don't know this. Hell, I didn't know this a year ago, guys, so don't be concerned if you didn't know this, but front and rear heights are very, very, very specific to Dolby Atmos. One thing you must encounter is if you have rear heights and you have those rear heights turned on, or if you have a voice of God or anything but these two front heights right here, you will not be getting Dolby Atmos. Why? Dolby Atmos is a little bit different than DTS:X. Dolby Atmos is configured or designed specifically to work with front height channels. Yes, it can do 4 height channels entirely, but if you're going to have height channels, the first 2 of them must be those 2 front height channels. Why? That's the way they designed Dolby Atmos. DTS:X is not like that, but for Atmos, you must have the 2 height channels. So, if you are running everything that's got Atmos, and you're not getting the Atmos, even through an audio return channel, it's possible, it is possible, let me tell you this. You need to do something though. What you need to do is go into your receiver configuration. If you've got any height set up whatsoever, make sure you're running only the front heights, because I had this problem with my 7010 guys. I was running rear heights, and I wanted those rear heights on only, and I wasn't running the front heights for a little bit, and I'm not getting Atmos. Well, as soon as I changed my rear heights to the front heights, and it just took me a matter of hanging those speakers from the rear wall to just zip, zip, plugging them on into the front stud, mounting places I've got there. Changed a listening configuration. I just changed it to the different mix like that, and sure enough, we had our True HD at the bottom right here, and then we go on up, and there's Atmos, and it's like, aha, there we go, beautiful, got it, perfect, problem solved. But for most people, they're just not realizing what the heck it takes to achieve the Dolby Atmos like that through different devices, through an HDMI audio return channel. Why? Different source material, guys. It's not the source material that's determining it. I mean, the source material does determine if you're having Atmos or not. But if you're running something like this, it's going to have Atmos. But you need to determine not only what sound mode you're in, those heights. So if you've got a problem with Atmos and you're not getting the Atmos, put it in the comments section, please. If your source material is meeting Atmos configuration, if your receiver is meeting Atmos's needs, and everything else is, but you're still not getting it, there's something you're not doing, or there's some setting that you haven't configured properly that is not allowing you to get that Atmos. So, once again, I will explain the fact that audio return channels, crosstalk, can handle Atmos. However, you need to make sure your configuration is set up in a manner at which Atmos can be basically decoded or talked back between the television and the receiver. So once you've determined that everything is set up for Atmos, you've got your TV, audio return channel hooked up to your receiver, and you're still not getting it, you've got to make sure you are not sending PCM out of anything, including the TV, the source material, and yes, your receiver. Once you swipe that PCM out and you make sure you're getting bitstream on everything, and you're still not getting Atmos, configuration. It's all in your configuration. I can almost guarantee it. So go into the configuration, reset things if you have to. Don't go back to your default, from the manufacturer, but reset your setups, if you've got to, and then try again, because I can almost guarantee you if, your source material, and what I mean by source material now is not necessarily a Blu-ray, but something streaming. If your source material has Atmos and you're not getting it, then there is something with your configuration. As long as you've got that little, this is the one place we need this symbol, guys, on the receiver. If we've got this symbol on the receiver, obviously the source material too, you should be able to get it. But a lot of times it's in the configuration. If you've got rear height set up, if you've got one voice of God for Oro 3D set up, it's going to screw stuff up. So once we go ahead and configure our soundstage or to be correct to Dolby Atmos, we'll be getting Dolby Atmos. So I hope this video helped, guys. There's a ton of more literature I could give you. I could throw specifications and technical aspects and features to you all day, but we're going to get bored of that. And yeah, so we're just not going to understand it that way. I mean, I can give you the technical aspects of it, but it's just going to bore people, and I don't think we're going to get the gist of it. So I hope we've understood things. If we haven't, please let me know. I'll try to explain it in a more understandable method or way of understanding it that, we can all sort of take part in. But yeah, if you need help still, let me know. If you're not getting Atmos, please let me know. Tell me what items you're using, how you got things set up, and source material. What source material? If it's Voodoo, if so, what's the title of the film called? Let me know. Let me know if people's problems out there, and I'll give you an extra little thumbs up if you're doing things right. If not, let me know. Let me know, please, guys. Thank you, and please subscribe.